Hello surveying students, this is John Hannon, and the video at hand has to do with chapter 6, bearings and azimuths, converting back and forth. And what we're looking at is a spreadsheet. Now, the book goes to great pains to say that it's hard to create formulas and make these conversions happen automatically. And they emphasize the need to do a sketch, which I agree with. But I'm going to do some of this nonetheless in a spreadsheet. But I'm going to show you how I do it. Maybe it will be a little added value from the text, because it doesn't make sense to me. This is just me personally to do it another way. And that has to do with, this is the practice problem 6 from the text. So the answers are in the back of the book. And I encourage you to practice with this table. I'll no doubt give you some problems from an odd numbered table, most likely. And this table has bearing. Sometimes they give you a bearing. In this first case, they want you to convert to a north azimuth and a south azimuth. Most textbooks that you see don't deal with southern azimuths because we're in North America and they're just not very common in the northern hemisphere. But nonetheless, the book has this table like this. So from the bearing, they want you to convert to a north azimuth and a south azimuth. And then you can see you're given different azimuths and bearings and asked to complete the table for the other two types. And the way I think of it, you may want to create your own notes similar to this, but since we're talking about angles, right, and angles are 360, so if you think of everything in a quadrant like this, hopefully you remember that the top would be 0, and as I go around this circle counterclockwise, I'm going to hit 90 degrees right here before I go into another quadrant, which is also 90 degrees. So by the time I get turned all the way down here, 90 plus 90, I'm at 180, and I travel another 90 around the circle, I'm at 270, and then home is 360 or 0 again. Okay, and so just taking, this thought of quadrants over here, we can label these. I think they're labeled backwards from high school geometry. So if we label them 1, quadrant 1, quadrant 2, 3, and 4, then we can make some general rules about converting from azimuths to bearings and bearings to azimuths. Okay, so for instance, here in this quadrant, what I'm showing is that's the northeast quadrant, or number 1. So if we think of north at the top, south at the bottom, east on the right, and west on the left, that's how we come up with northeast. And this is an easy one because the azimuth is the bearing. All right, so those are easy. So this one would be 30 degrees, 40 minutes. That's a no-brainer. All right, because that is, it's in the northeast quadrant when you're given a bearing. When you're giving an azimuth, you're not, you don't know the quadrant unless you sketch it out, or in this case, you're given 120 degrees. All right, so we know that's greater than 90, and less than 180, so it's got to be in this quadrant, which would be the southeast quadrant. Except that's a southern, that's not true, because that's a southern azimuth. All right, so I'd have to be coming 120 from a southern azimuth this way, which would put me beyond 90 degrees, and that's northwest. And that's why we got to sketch them and make sure. So what I like to do is, excuse me, the way I do these tables is I just go through and figure out what quadrant they're in, and I just label it. That's me. But let me keep going through these formulas. The southeast quadrant, the formula is from, if you have a bearing and you want an azimuth, it's 180 degrees minus the bearing. And I've found that a lot of times you have to go 179 degrees 60 seconds to do the math. In the southwest quadrant, if you want an azimuth and you have a bearing, you need to add 180 to the bearing. And then in the northwest quadrant, it's 360 degrees minus the bearing angle. And then just the opposite down below, again, the northeast quadrant is an easy one. So the bearing equals the azimuth. In the southeast quadrant, the bearing equals 180 degrees minus the azimuth. Southwest is your azimuth minus 180. And then your northwest, your bearing equals 360 minus the azimuth. So you can like compare these and maybe it will start to make sense. Okay. So again, what I do is go through and I just like to get my quadrant. That helps me. And making a sketch is pretty important too. I'm not gonna sketch, but just to give you some ideas, let me minimize this. What I'm looking at here, this is Civil 3D. It's an Autodesk product, and it's for creating contract documents, drawings from survey data. Civil 3D from Autodesk. You actually can get a free license for this through your enrollment at USM. You just need to go to Autodesk and register, and you'll be able to download it and play with it. But for instance, if I want to come in here and I can create a line by azimuth. All right, so I choose that, pick a spot, and you can see I just did a click, and it shows me the north azimuth automatically, and it's showing a little symbol there for a transit, for a total station, an instrument on a tripod, and then the pink is a prism or a rod. And again, everything is referenced from the north meridian. This would be a north azimuth. And you can see I'm coming down here right about to parallel, and I'm getting very close to 180. All right. And so forth and so on. Okay. I can also just put in the azimuth, and it will draw it. It'll draw the line, but you gotta be sure you're not thinking in terms of a back azimuth. You're in point. So in the table that we were looking at, the very last one, the azimuth is 130, 30 degrees. Now, once a distance, this chapter 6 doesn't deal with distance. We will in chapter 7, because all of these chapters are cumulative to get us really to chapter 7 and beyond. And, we turn these angles, azimuths, and bearings to create, for one thing, traverses. And traverses are about angles and distances. But not really going to worry that much about that. And so now I'm, guess I could just delete that, and this would be the quadrant right here. If I put my X here, you can see that's the southeast quadrant based upon my stuff. And I think I can actually, you can cheat with this. I think you can actually have it calculate the bearing for you. Let's see if I can pull that off. Let's see, give me the bearing. And there we go. If you want to cheat, it's not cheating to me if you can use this tool. That's actually the correct answer in the book. The bearing is south 49, 30 minutes. Okay. And then the other thing, I'll just to keep in mind, with this tool, you can also create a line by a bearing. If I click a point, see, it's asking me what quadrant. Am I in quadrant 1? You can see where the cursor is. It says quadrant 1 northeast, quadrant 2 southeast, 3 southwest, and so forth. Now, if I come down here and I put in if I specify quadrant 2, notice it won't let me go beyond 90 degrees. So it wants to know a quadrant, and that's why the bearings are never greater than 90 degrees. Right? Okay, so we can come back to this table, and again, what I like to do is determine the quadrant, or maybe determine the north azimuth first. So here we would, if the azimuth is 120 south, all right, so it'll be somewhere up in here. That would be the northwest quadrant. Whoops. Oh, they're both northwest. This one here would be 120 plus 180. So once I have my north azimuth, all right, then I know it's greater than 180 coming from the north. Remember, the north azimuth coming around, it's greater than 270. So I've got to be in this quadrant over here, and I just need to subtract 359 degrees 60 minutes from 310. Let's see if I can pull that off. Let's see, 359 60 seconds minus this. And then I would need to put the N and the W in here, because this bearing would be north 59 degrees 50 minutes west. Okay. And this is my basic way that I do this. I determine the north azimuth so I can determine which quadrant and which formula to use, and then calculate my bearings, and then the azimuth. And these two typically deal with 180 degrees, not always, but typically, I guess always. And make a run through that. Obviously, this is the northwest quadrant. This one would be a north azimuth, which is given. It's going to be just right up in here somewhere. So that's an easy one. It's going to be in the northeast. Oops. And it'll be 10.3. And then we add 180 to that to get the south azimuth. Equals 180 plus this. So the south azimuth is 190 degrees, 30 minutes. Remember, the azimuths don't have direction. They're just a pure angle. All right. Typically why surveyors like to use them for calculating. The bearing is nice when you're trying to give directions, especially on traverses, plot plans, things of that nature. So there's a place for both of these, and it's important to know how to go through and convert between typically just a bearing and a north azimuth. So practice with this table, okay, and I'll put up some problems that are similar to this. Hope this was helpful. Thank you.